Professor Physics in the Department of Physics, Maharaja Jivaji Rao Shinde College, Srigonda, Ahmednagar. We have started our second chapter, that is study of transistors related to SYBSc electronic subject, and we have covered the points what is transistor and what is the construction of transistor. In that we have seen the construction of NPN transistor and PNP transistor. In today's lecture we will see what is the circuit symbol of this NPN and PNP transistor and what is the operation of or the operating principle of NPN and PNP transistor. So first point we are going to see is the circuit symbol for NPN transistor and circuit symbol for PNP transistor. During our last lecture, we have seen how to construct a NPN transistor and how to construct a PNP transistor. In case of NPN transistor, a p-type material, semiconducting material, is sandwiched in between two n-type materials, and in case of PNP transistor, a n-type semiconducting material is sandwiched in between two p-type semiconducting materials. Thus, there are the creation of two diodes inside this NPN transistor and two diodes inside the PNP transistor. Now, the circuit symbol of this NPN transistor is given by, because any transistor consists of three circuit components, and these are emitter, base and collector. Here also NPN transistor also consists of emitter, base and collector. So the circuit symbol for NPN transistor, it means that this is a base, this is emitter portion and this is collector portion. This is the circuit symbol of for NPN transistor. In case of NPN transistor, if you recall, the current flows from emitter to base, but actually the conventional current is moves from positive to negative, and these are the NPN made up of N type of material. It is made up of P type of material. It is made up of N type of material. Therefore, the conventional current flows from positive to negative. Hence, this is the symbol for NPN transistor. In case of PNP transistor, again we will have three terminals. One is the base. Here, base is made up of N type of material, and there is one this portion is called as emitter and this is collector. These are the three terminals which the NPN transistor have, and this is made up of N type of material. Here, emitter and collector are having p-type nature. P-type, p-type. Just now I have told you that the conventional current flows from positive to negative. Therefore, positive to negative, because here also current flows from emitter to base. Hence, the circuit diagram or circuit symbol for PNP transistor is as shown in figure. These are the two circuit symbols for NPN and PNP transistors respectively. Now we will move towards the working principle of NPN and PNP transistors. Let's draw the figure same as the previous, but we will attach the batteries in the circuit. Second point that we have to cover is working principle of NPN and PNP transistors. Now, initially we will start to draw the diagram related to NPN transistor. NPN transistor consists of a P type of material sandwiched in between two N type of materials. I have already told you that the base region is having smaller size as compared to emitter and the collector, and as compared to the emitter, the length of the collector is more in order to dissipate the heat and collect maximum number of electrons. Therefore, this is the emitter portion, this is the base portion, and this is the collector portion. Now we will show, and in case of NPN transistor, the majority charge carriers in emitter, these are the electrons, and they will move from emitter to base. In case of this transistor, the minority charge carriers are the holes which are located in the base region of the transistor, and collector is also made up of the electrons, but the doping as compared to emitter is less in case of collector. Now we have to forward bias the, now there are two junctions. First junction is between emitter and base. This is the junction. And second junction is between base and collector. This is the junction between base and collector. These are the two junctions. Now we have to forward bias the emitter base junction. In order to forward bias the emitter base junction, this is N type material, that is the negative. Therefore, when we connect the battery in the circuit such that the N type of battery is connected to emitter, and P terminal of the battery is connected to base, that is there are the holes, means positive, and this will give us a forward bias. Now, base collector junction is reverse bias. Base collector junction is the reverse bias. Therefore, in order to make it reverse bias, and we know that the reverse bias will have high resistance, and therefore here reverse bias means this portion is negative. Therefore, positive of battery should be like this. Positive of battery is connected to the collector of the transistor, and this battery is called as VEB, and this is called as VBC or VCB. Therefore, when we forward bias this emitter base junction, then electrons will start to migrate from emitter to base. They will cross this barrier and will come to the base section of the transistor, and in base there are the minority charge carriers, that is hole, and the electron hole recombination takes place. During our last lecture, I have told you that in case of the electron hole recombination, their percentage of recombination is about 5%. Therefore, 5% of the electrons coming from the emitter will get utilized here and they will contribute the valence electrons and they will create a current and it is called as base current. Due to the migration of electrons inside the emitter, there will be generation of emitter current. And now this 95% of the remaining electrons will cross this barrier and will come to the collector section of the transistor and they will give us the collector current IC. This is the working principle of Npn transistor. If we see this portion is having forward bias, therefore its resistance is less. Resistance is less. And this portion is reverse bias. So resistance is more. And hence, if we follow the Ohm's law, that is V is equal to IR, then there will be the amplification of the current or the power. Therefore, this will give rise to amplification of the current in output section of the transistor. Therefore, input will get amplified due to the variation in the resistance because in output section resistance is more. So let's revise the things related to working principle of NPN transistor. NPN transistor is the transistor in which a p-type material is sandwiched in between two n-type materials, and this is the diagram for the working principle of NPN transistor. Here there are three terminals: emitter, base and collector. In our previous lecture we have seen how emitter is formed, how collector is formed and how base is formed. The length of the collector region is purposefully made larger than that of emitter region in order to collect maximum number of electrons coming from the emitter to the collector section, and in order to dissipate the heat. The base region is the lighter portion of the transistor and it consists of minority charge carriers, that is holes. When we forward bias the NPN transistor, then during forward bias resistance of the junction is less and this portion of the transistor is reverse bias, and because of that the resistance of the junction is more, and due to this change in resistance there will be increase in current or the increase in power, and therefore the transistors are used for amplifying actions. When we forward bias this emitter base junction, then electrons will start to migrate from emitter to base. Here electron hole recombination takes place and about 5% of electrons will get recombined with holes and remaining 95% electrons will migrate through the collector or get collected into the collector section and will give rise to IC, that is collector current, and therefore the current in the circuit will flow like this. And here for biasing purpose we have used these two batteries. Here the capacity is less because it is forward bias and this is in reverse bias resistance is more. This is the working principle of NPN transistor. Thank you.